Welcome to the deep dive. Today, we're pulling back the curtain on the silent workhorses of our cities. Aluminium angles and channels. You probably walk past them every single day, never knowing that these seemingly simple pieces of metal are actually, well, the secret ingredient. They're enabling designs and structures that were once just architectural dreams. We've poured through a stack of sources to uncover why these precise profiles have become such a cornerstone of our built environment, from the soaring heights of skyscrapers to the intricate spans of modern bridges. Think of this as your shortcut, really, to understanding the hidden strength and astonishing versatility that truly shapes the world around us.
It's absolutely true. While they often operate behind the scenes, their impact is nothing short of immense. This deep dive will uncover not just what these extruded profiles are, but how they provide that crucial structural integrity and unlock incredible design flexibility. We'll explore their fundamental characteristics, their myriad unexpected applications, and even look at how they stack up against traditional materials in some surprising ways.
So, if you've ever found yourself wondering what truly holds up a dazzling new building, or, how architects achieve those sleek contemporary designs that seem to defy gravity, stick with us. You're about to become incredibly well informed on a surprisingly captivating topic. Okay, let's unpack this. When we talk about aluminum angles and channels, what exactly are we picturing, and what makes this specific form so crucial in modern construction?
Essentially, we're talking about extruded profiles. Imagine pushing a continuous length of, say, Play-Doh through a shaped nozzle. That nozzle is called a die. And it's how we create these incredibly precise, consistent shapes by forcing heated aluminum through it. Angles come in L shapes, both equal and unequal sides, providing vital support and reinforcement. Channels, on the other hand, are typically U or C-shaped, offering stability and forming frameworks. Their importance goes beyond just the shape, though. It stems from the unique combination of structural integrity they offer and their contribution to a building's aesthetic appeal. They are fundamental precisely because of their lightweight nature, an inherent resistance to corrosion that other metals just can't match, and, well, how incredibly easy they are to fabricate and manipulate. This versatility is what really sets them apart.
So they're not just about raw structural strength, they're also key to achieving those impressive, clean designs. That's a powerful one-two punch, isn't it?
It absolutely is, yeah.
Let's dig deeper into the core reasons why these aluminum profiles have become indispensable. What are the standout benefits that make them the go-to choice for so many modern projects?
Well, the first, and perhaps most revolutionary, is their exceptional strength-to-weight ratio. Aluminum angles and channels offer significant structural support without adding excessive weight. Now, the insight here is, this isn't just a technical spec. It fundamentally reshapes the economics and aesthetics of modern high-rise building. I mean, imagine designing a skyscraper. Every kilo saved on the upper floors reduces the load on the foundations exponentially. That leads to enormous savings on materials and labor, and it opens the door to incredibly lightweight, soaring glass structures that would have been impossible decades ago.
Wow. Okay, that reduction in load is huge.
Exactly. Then there's corrosion resistance. Unlike steel, which rusts when exposed to oxygen and moisture, aluminum naturally forms a thin, incredibly tough, self-repairing oxide layer on its surface.
Self-repair.
Yeah, it sounds like science fiction, but it's true. This layer acts as a permanent shield, making it exceptionally durable in outdoor or high-moisture environments. Think coastal buildings or bridges without needing constant protective coatings. That's a huge maintenance saving over the lifespan of a structure.
That's truly fascinating, that self-repairing shield. So no rust, less weight. What about that design flexibility you mentioned earlier? How does aluminum's inherent nature translate into, architectural freedom?
Right. Their versatility and flexibility are indeed remarkable. Because of that extrusion process we talked about, they can be customized into an almost endless variety of shapes and sizes, whether it's for complex framing, precise reinforcement, or even purely decorative structures. This ease of fabrication allows builders and architects to create designs that are both structurally sound and visually stunning, without compromise. It's quite freeing.
Okay, so the shape isn't a limitation.
Not really, no. And finally, there's their aesthetic appeal. They have a naturally smooth finish, which is nice. Plus, they can be anodized. That's an electrochemical process. Basically forms a super durable protective oxide layer, often with integrated color or powder-coated. Powder coating is like a very tough paint finish, gives you a huge range of colors. This means they seamlessly integrate into modern designs, whether it's sleek window frames, elegant facades, or decorative trims. They add a touch of sophisticated, clean-line elegance.
It certainly sounds like these profiles are incredibly adaptable. Where do we typically see aluminium angles and channels in action? Where does it get really interesting, maybe in places you wouldn't expect?
Oh, they truly play a vital role in structural frameworks. Their high strength-to-weight ratio makes them ideal for load-bearing applications, everything from high-rise buildings to massive industrial frameworks, ensuring durability with minimal maintenance. Think about the intricate lattice work you sometimes see on modern stadium roofs that's often aluminum, enabling those vast unsupported spans. It's pretty cool.
Right, those huge roofs. I never thought about what holds them up.
Exactly. And beyond raw structure, they're absolutely critical in architectural designs. Modern projects use them extensively for sleek, visible elements. Things like expansive window frames, elaborate curtain walls, and striking facades. They're not just hidden away, they blend aesthetic appeal with structural strength, and their lightweight nature dramatically simplifies installation on site. It means you can have those enormous glass walls without needing a colossal steel substructure underneath.
So they're not just supporting, they're actually shaping the look and feel of our urban landscape. That's a huge shift from purely functional materials.
Precisely. And they're also widely used for support and reinforcement in countless everyday construction projects, from roofing structures to retail shelving units and interior partition framing. They provide essential stability and longevity in places you might not even notice.
Okay. So shelving too?
Yeah, absolutely. And critically, they contribute significantly to infrastructure development. Think about the modern, often intricate staircases and handrails in transport stations, or the elegant pedestrian bridges you see in public spaces. Their weather resistance and sustainability make them a cost-effective, long-term solution for railways, airports, and urban developments where longevity and low maintenance are paramount.
So given all these benefits you've outlined, how does aluminium truly stack up against the traditional materials we're more familiar with, like steel or wood? This raises an important question. Is it always the best choice, or are there situations where other materials still hold an advantage?
It's an excellent comparison to make because, no material is a universal panacea. But let's look at why aluminum often comes out on top. First, aluminum versus steel. Aluminum offers comparable strength for many applications, but is significantly lighter, typically about one-third the weight of steel for the same volume.
One-third.
Yeah, it simplifies handling and installation dramatically. Crucially, as we discussed, it doesn't rust. That eliminates the need for the heavy, often toxic protective coatings that steel requires, especially outdoors. Now, for extremely heavy, concentrated loads, or in very high-temperature applications where stiffness is paramount, steel often still has the edge. Let's be clear on that. But aluminum allows for far greater design adaptability and customization in most cases.
Okay, that makes sense. What about wood?
Right, aluminum versus wood. Here, aluminum provides superior durability. It won't warp, crack, rot, or be susceptible to pests like termites. It's also non-combustible, offering enhanced fire safety, which is a major concern in many building codes.
Huge factor, fire safety.
Absolutely. And from an eco-friendliness perspective, aluminum is fully recyclable, contrasting with the deforestation sometimes associated with unsustainable wood harvesting. Wood still shines for its natural aesthetic in certain applications, of course, and its thermal insulation properties can be better, but it demands far more maintenance over time.
Gotcha. And briefly, other things like plastic or concrete.
Well, versus plastic or concrete, while plastic is lightweight and cheap, it simply lacks aluminum's structural strength, stiffness, and long-term durability. It's just not in the same league for structural uses.
Yeah.
Concrete, on the other hand, is incredibly strong in compression but very heavy, and has a higher carbon footprint in its initial production. Aluminum's high recyclability and increasingly energy-efficient production make it a much more sustainable choice in the long run, especially considering the whole life cycle.
That really does put its advantages into perspective, especially when you consider the whole life cycle of a structure. It sounds like its versatility and eco-friendliness are making it increasingly dominant. It's clear aluminum is a powerhouse, but what are the very latest advancements in this field? What's genuinely fascinating right now in how we're pushing the boundaries of aluminum use in construction?
Oh, innovation continues to enhance its capabilities significantly. It's not static at all. We're seeing exciting developments in advanced alloy compositions. These new alloys are engineered, basically, to boost specific properties like load-bearing capacity, extreme corrosion resistance, or overall durability. This makes them ideal for long-term construction use, even in the most harsh, demanding environments. Think Arctic pipelines or desert solar farms.
Wow, okay, so tailoring the metal itself.
Exactly. Then there are smart manufacturing and extrusion techniques. Imagine using AI-driven precision die designs and automated processing. These innovations, combined with enhanced heat treatments, ensure consistent quality and dimensional accuracy like never before. This translates to faster production cycles, significantly less material waste, and the ability to create highly customized, intricate solutions with unprecedented precision. It's getting very sophisticated.
So it's getting stronger, more precise, and faster to produce. But you also hinted at its environmental footprint earlier. What's happening on the sustainability front?
Sustainability is a colossal focus, and it's where aluminium truly shines. It's already 100% recyclable without any loss of quality, which is remarkable in itself.
Yeah, infinitely recyclable. Right.
Pretty much. But new developments include low-carbon and energy-efficient production processes for primary aluminium, the new stuff. Plus, there's an even greater emphasis on using recycled aluminium, which requires only about 5% of the energy of primary production. That's a huge saving. Eco-friendly coating techniques also further reduce environmental impact, aligning perfectly with global green building standards and the drive towards net zero construction. It's a material that truly embodies the circular economy.
That's really encouraging to hear. So if you, our listener, are looking to use these in a project, perhaps you're an architect, a builder, or even just planning a significant home renovation, what should you keep in mind to pick the right profiles for your specific needs? Any key takeaways?
Yeah, several factors are absolutely crucial to get right. First, you really need to consider the size and dimensions carefully. They need to align precisely with your load-bearing needs, any space constraints you have, and the specific demands of your application. Getting this wrong can lead to over-engineering, which costs more, or worse, structural weakness.
Right. Don't want that.
Definitely not. Second, thickness and strength are vital. Heavier-duty applications like a structural beam will obviously need thicker, more robust profiles, while lighter structures, say for decorative trim, can use thinner sections very efficiently. Save material where you can. Most importantly, always assess the load capacity and structural stability required by your design to ensure long-term safety and performance. Get an engineer involved if needed.
Good advice. And beyond the standard sizes, what about customization? I know that's a huge draw for this material.
Absolutely. Customization options are a massive advantage that aluminium offers. This includes tailoring shapes and finishes to specific aesthetic or functional needs. It also means selecting the perfect alloy composition for specific strength or corrosion resistance requirements, which we just talked about, and even precision cutting and fabrication with pre-drilled holes. This can dramatically enhance installation efficiency and significantly reduce on-site labor, saving both time and money for the project.
What a deep dive. We've really covered how aluminium angles and channels are not just vital to modern construction, but truly remarkable in their strength, incredible versatility, and undeniable sustainability. From literally holding up our tallest buildings to adding that sleek, sophisticated finish to our homes and offices, they are truly the unsung heroes of our built environment.
They genuinely are. They offer architects, engineers, and builders high-performance, cost-effective, and increasingly environmentally conscious solutions. And as industries continue to evolve and demand more from materials, the need for high-quality aluminium sections will only grow. It'll keep driving innovation in both design and functionality for decades to come, I think.
So the next time you look up at a gleaming skyscraper, walk across a sleek new bridge, or even just notice the framing around a modern window, you now have a much deeper appreciation for the quiet, invisible, yet incredibly important role these extruded aluminium profiles play. They really are a testament to how intelligent material choices can fundamentally shape and elevate our world.
Indeed. And this raises an important question perhaps for you to consider. As we continue to push the boundaries of design and sustainability in construction, what other seemingly simple everyday materials might be hiding similar profound capabilities that are yet to be fully explored or appreciated by the masses? What quiet revolution is already underway that we haven't quite noticed yet?